Hi, welcome back to my channel wherein mathematics is never hard. In this tutorial video, we are going to derive quadratic function from table of values. So this is one of the competency in grade 9 mathematics for the first quarter under quadratic function. So the scenario is you'll be given a table of values and then you're going to derive a quadratic function. But for this video, this is somewhat special because what I'm going to teach you is not the conventional way of deriving a quadratic function from the table of values. So if you are going to look at your books or your learner's materials or your modules, when you are presented with this table of values, one of the most common method in solving this one or having an equation for the quadratic function is to use the system of linear equations. And if you are going to look at the solutions and knowing your personality, you will surely surrender. That's why I look for this Forbidden Jutsu, because after watching this video, you can easily derive an equation for your quadratic function represented by a certain table of values. But you take note of the title of this slide. It's called the Forbidden Jutsu because what I'm going to teach you is not going to work for all these type of problems. We have some criteria to meet before we can use this technique, but based on my research, and you're very lucky because almost all of the problems in junior high school when it comes to like this falls under this situation, meaning we can use this technique. So before I'm going to show to you the real solution, let me first clarify to you what should be the criteria that we are going to meet. First, when you look at the x values, try to find the difference. The difference should be equal to 1 before we can use this technique. So if you are going to subtract, so let us check. 2 minus 1 is 1. 1 minus 0 is equal to 1. 0 minus negative 1 is just equal to 0 plus 1, so that's 1. And negative 1 minus 2 is negative 1 plus 2 is equal to positive 1. So as you can see, all the differences are equal to 1, meaning we are able to meet the first criteria, wherein the differences in the x values should be all equal to 1. Second criterion is there should be 0 on the x value. And I think it's very visible that among the x values there is 0. So we were able to meet the second criterion. The third criterion is there should be 1. They are so sweet. They should be together in order for this Forbidden Jutsu to work. So there should be 1. So we have 0 and 1. So those are the 3 criteria that we are going to check first before jumping into this forbidden technique. So before I'm going to show to you the solution, let me first erase these markings. Erase. Oops. Okay, let us proceed. After checking if the given table of values were able to meet the criteria I'm talking earlier, we can now proceed. first thing you're going to do is to find the differences in y. So 9 minus 4 is equal to 5. 3 minus 4 is equal 4 minus 3 is equal to 1. This is very important. We need to do it from right to left all the time so that this technique will work. 3 minus 6 is equal to negative 3. 6 minus 13 is equal to negative 7. So as you can see, the differences are not equal, meaning this table of values, we are sure that this is not representing linear function, because if we are going to recall, for linear function, the first differences should be equal. So now let us proceed with the second differences. Again, from right to left, find the difference. 5 minus 1 is equal to 4. 1 minus negative 3 is just equal to 1 plus 3, so that is equal to 4. Negative 3 minus negative 7 is negative 3 plus 7, so that is positive 4. So as you can see, the second differences is equal to 4. So what is nice with this technique is we can also verify if the given table of values is really representing a quadratic function, because once we can get second differences having the same value, then we are sure it is representing a quadratic function. Because sometimes, and it's happening on your modules, the given table of values is actually not representing a quadratic function, because there are some entries, maybe they are products of typographical errors. So you are exerting too much effort leading to nothing. So with this technique, that will not happen, because before you are going to proceed with the final solution, you can verify if it's really representing a quadratic function. So again, this technique is my way, and this is the easier way. Now you take note of the second differences, or the value of the second differences, that is equal to 4. So the second difference is equal to 4. So why I put emphasis on this, because this 4 will be used to find the value of A. Again, remember, the second difference will be used to find the value of A, and the question is how. The answer is this. The value of A is equal to 1/2 of the second difference, meaning what's the value of the second difference? Just take the half of it, or simply you divide the second difference by 2. So if you can recall, the second difference earlier is equal to 4. That's why for the value of A is equal to 1/2. 1/2 times 4. Again, 4 is the second difference as presented in the previous slide. And what is 1/2 times 4? That is equal to 2. Meaning, the value of A is equal to 2. Now, why I'm talking about the values of A, B, and C? Because at the end, we will be deriving a quadratic function in standard form. So recall, for the standard form, it is f of x equals ax squared plus bx plus c. So basically what we need are the values of A, B, and C. And what we have already is the value of A. So let us proceed to the values of B and C. So going back to the table, after finding the second differences, or the value of the second differences, let's have this one. What's the difference between y values when x equals 0 and x is equal to 1? So to put emphasis, when x equals 0, this one, and when x is equal to 1. But if you can understand this phrase, the difference between y values. So our concern is the difference between the y values. So we are going to look at the y values. So when x is equal to 0, that is equal, y is equal to 3. When x is equal to 1, y is equal to 4. And if speaking about difference, our operation should be subtraction. But this time it's easier because we already subtracted the y values earlier, and that is equal to 1. So again, where do we get 1? It is the difference between y values when x equals 0 and x equals 1. And you might be asking, sir, is that the scenario always? Yes, that's why for this technique to work, there should be values of x equal to 0 and equal to 1 respectively, because if these values are not present, then this technique I'm teaching you will not work. Now you take note of this value, because we are going to use this value. So moving on to the next slide, this will be the step in finding the value of b. A plus b is equal to the difference between y values when x equals 0 and x equals 1. Recall that these phrases, or this phrase, is equal to 1 as I presented earlier. That's why we can have a plus b is equal to 1. And again, where did we get 1? We get 1 as the difference between y values when x equals 0 and x equals 1 as shown in the table. But earlier, we already know that the value of a is equal to 2. So meaning we can substitute 2 to the value of a, so that will become 2 plus b is equal to 1. And the rest is history. We are going to solve for the value of b. So solving for b, that will become b is equal to negative 2 plus 1. Why negative 2? Because we transpose positive 2 to the other side, making it negative. And negative 2 plus 1 is equal to negative 1. That's why b is equal to negative 1. So now we are done with the value of a and the value of b. Finally, we can have the value of c, and the value of c is very simple. We are just going to find f of 0, meaning what's the value of y when x is equal to 0. That's the meaning of this. Find f of 0. What's the value of y when x equals 0? So first, we are going to look for 0 under x values. So we have 0, and then you look at the value of y. The value of y is 3, meaning f of 0 is equal to 3. So remember that value because we are going to use that on the next slide. The value of c. The value of c is simply equal to f of 0. So again, what's the value of y when x equals 0 is also the value of c. So now we have c is equal to 3. And collecting together what we have earlier, b equals negative 1 and a equals 2, we can now have our quadratic function in standard form. F of x equals ax squared plus bx plus c. So what we are going to do is just to substitute these values into this form. So we are going to have f of x equals a is equal to 2. So we will have 2x squared plus bx, but this time our b is equal to negative 1. So instead of plus, we can have minus 1x. And then, since we have minus 1, we do not need to write 1. Instead, we can have minus x plus the value of c, which is 3. So final answer, f of x equals 2x squared minus x plus 3, wherein a is equal to 2, b is equal to negative 1, and understood this x has a numerical coefficient of 1, that's why b is equal to negative 1, and we don't need to write 1 on this part, and c is equal to 3. I think this technique will help you as long as you know how to check the 3 criteria I presented earlier. Now, if you want another example, just replay the video and then you can have another example. So thank you for watching and enjoy learning mathematics. So this is Aguila at your service. Bye bye.